Scientists discover a 2 billion-year-old natural nuclear reactor in Africa. 2 billion years ago, parts of an African uranium deposit spontaneously underwent nuclear fission. Scientists estimate that this nuclear reactor WHCH consists of 16 sites, has been operational for at least 500,000 years in the distant past. Incredibly, compared with this massive nuclear reactor, our modern-day nuclear reactors are not comparable both in design and functionality. The nuclear reactor consists of 16 sites. As it is noted in Scientific American, it is truly amazing that more than a dozen natural reactors spontaneously sprang into existence and that they managed to maintain a modest power output for perhaps a few hundred millennia. The discovery is so fascinating that researchers said that the discovery of the Oklo natural nuclear reactor in Gabon, West Africa, in 1972 was possibly one of the most momentous events in reactor physics since 1942, when Enrico Fermi and his team achieved an artificial self-sustained fission chain reaction. Whenever we hear the term nuclear reactor, we think of a structure created artificially. However, that's not the case here. This nuclear reactor is in fact located in a region of natural uranium within our planet's crust, located in Oklahoma, Gabon. As it turns out, uranium is naturally radioactive, and the conditions that occurred in Oklahoma happen to be perfect, allowing nuclear reactions to take place. In fact, Oklo is the only known location for this on the planet and consists of 16 sites at which scientists say self-sustaining nuclear fissions occurred around 1.7 billion years ago, averaging around 100 kilowatts of thermal power during that time. The Oklo uranium ore deposits are the only known sites in which natural nuclear reactors existed, but how? Why is it that no other place on Earth has a natural nuclear reactor? According to reports, the natural nuclear reactor formed when a uranium-rich mineral deposit became inundated with groundwater that acted as a neutron moderator, and a nuclear chain reaction took place. The heat generated from the nuclear fission caused the groundwater to boil away, which slowed or stopped the reaction. After cooling of the mineral deposit, the water returned and the reaction restarted, completing a full cycle every 3 hours. The fission reaction cycles continued for hundreds of thousands of years and ended when the ever-decreasing fissile materials no longer could sustain a chain reaction. This mind-bending discovery was made in 1972 when French scientists took uranium ore from the mine in Gabon to test its uranium content. Uranium ore is composed of 3 isotopes of uranium, and each one of them contains a different number of neutrons. There is uranium-238, uranium-234, and uranium-235. Uranium-235 is the one which scientists are most interested in because it can sustain nuclear chain reactions. What is surprising is that a nuclear reaction had occurred in a way that the plutonium, the byproduct, was created, and the nuclear reaction itself had been moderated. This is something considered as a holy grail of atomic science. The ability to moderate the reaction means that once the reaction was initiated, it was possible to leverage the output power in a controlled way, with the capacity to prevent catastrophic explosions or the release of the energy at a single time. They also found that water had been used to moderate the reaction in the same way that modern nuclear reactors cool down, using graphite cadmium shafts, preventing the reactor from going into critical state and exploding. All of this, in nature, of course. After all, nature is incredible in every single way. But, why is it that these parts of the deposit did not explode and destroy themselves right after nuclear chain reactions began? What mechanism provided the necessary self-regulation? Did these reactors run steadily or in fits and starts?